What is this mycorrhizal we're seeing?
Mycorrhizal, Andrew. The motto is change your world, and that's what the green movement's all about, is change your world.
Does it change your world?
Yeah, I think so. This company has figured out a way to use less water and less fertilizers to grow all kinds of plants, including your fruit trees and your vegetables.
Mycorrhizal.
Mycorrhizal.
It's got to be complicated, hasn't
Yeah.
it? It's got to be, I just can't believe for a minute that this is just a simple, let's have a look at the logo. There's some roots there, there's some greenage, applications.
Yeah.
This is serious.
Don't hurt yourself, Andrew. Don't hurt yourself. It's all right. We're going to go talk to the scientist himself, Dr. Mike, and learn more about it.
Okay.
Man, Andrew, what a beautiful building. Look
Yeah,
at
it's
this
pretty
place.
impressive, I must admit.
Yeah.
Dr. Mike.
Welcome.
Andrew.
Don.
Welcome.
Yeah, beautiful building. Tell us a little bit about it.
Well, it's a green building, and we tried to make the building as green as the company and our mission. So,
Well, let's go back to your roots, if you'll forgive the pun. And can you explain to us exactly what this business is all about?
what we're doing is expanding the root system of the plant several hundred to several thousand times using naturally occurring beneficial soil organisms. It's a lot like this little white piece of root here.
See that?
Yeah, look at that.
Basically, an extension of the feeder root system of the plant, so the plant can get more nourishment in terms of water and nutrients out of the soil.
So how does it work then? What actually do you do?
We grow the seeds of these fungi, and we grow billions and billions of these seeds, and we put them in various mixes, and the plant roots trigger the little seeds to germinate, and they form these strings in the soil, which are really an extension of the root system. And that's what feeds the plant, are these little tiny threads in the soil.
So in like a really hot climate, like Arizona or somewhere where there's not a huge amount of water, is it effective in that kind of an environment?
Yeah, about 90% of the world's plants form this relationship in their native habitat. So we really haven't invented anything, we just learned how to grow the spores. And they're particularly important in environments that are very rigorous, like Arizona, where plants struggle to survive because they can really increase the amount of soil.
So you mentioned spores, so that means these are microscopic in size. You can only see them under a microscope,
They're
right?
tiny little critters, but they're really important. And these do occur naturally in environments. If you look like a redwood forest, these trees are 8 foot in diameter, 300 feet tall. They've never been irrigated, never been fertilized. It's this natural system which allows these plants to flourish in these tough environments.
So when did you start this business?
I started 35 years ago, so a long time ago, and I was trying to improve plant growth, and I was adding a lot of fertilizers, but the fertilizers weren't helping with a lot of the problems. In fact, they were making some of the problems worse with diseases, et cetera, by over-fertilizing. So we looked for a more natural approach and brought in the natural biology, and we were able to use less fertilizer and water and still have a healthy plant.
Man, oh man, what a fascinating company you have.
That's clever stuff.
So show us some more stuff.
Well, actually, can you take us to show us how this is actually, how you manufacture this?
Yeah.
Let's do that.
Yeah, when you look in the microscope, you'll see little tiny amber balls. And those are actually the apple on the apple tree. They're the fruity bodies. And so,
Fruity.
Amber balls, fruity
amber
body.
balls, and that's actually what we grow. And those are the seeds of these threads that grow in the soil.
The little brown thing, tiny little brown thing.
Right. They're actually,
Come on,
they're,
it's your turn. I wanna
they're
see
pretty.
They are actually.
Yeah.
They are.
They're like little,
They are.
little balloons.
Yeah, they're like gelatin and they're shiny and beautiful. They got outlined with nice little brown colors.
Stop
They're
plugging
really
them. I'll have
interesting.
another look. They're really nice. I like the darker brown ones more than the lighter brown ones. What's the difference?
All right.
Different species.
Are they really?
Good question.
But there's also round ones in
They're a
there.
natural. They're all actually round. The other
See, I
ones are
told
very
you, I had a
small.
future in science.
You're natural.
But what are you got round ones and long ones?
The long ones are actually spores inside of the root fragments. We use those as well. Yeah, so, you know, we put those near a root, they germinate like a seed germinates. They go into the root, they get their energy from the root, and then they produce this incredible cotton ball in the soil.
Wow.
It's that cotton ball that absorbs the moisture and the nutrients that the plant needs to feed itself.
So anybody can use your product on their plants.
95% of the world's plants form the relationship. There's some plants that don't form this relationship, but most of the common plants do.
So like, for our viewers, for example, having a hard time in his garden or his vegetable patch.
Right.
I mean, if we could get hold of your product, which you can, I know,
Right.
can Joe Blow do that at home and then suddenly see this flourishing?
It does. It helps, especially with fruiting and flowering, because that requires a lot of nutrients out of the soil.
Right.
So these little nourishing threads are really good at getting like phosphorus into tomatoes and peppers, or getting flowers to develop, because they require a lot of phosphorus.
What's next, Doc?
Well, have you guys seen the threads?
Oh, no.
This will change your life.
Oh,
Life-changing experience.
that's what it
Yeah.
says, change your world.
It does.
If you look in here, you'll see it looks like a cotton ball or a spider web. And you'll see some brown roots, but the roots are just nothing in comparison to this total mass of threads. There's probably 10 miles of threads.
But what
in that
about-
little piece
what
of
is-
soil.
what
That's
is
just
this?
That's just a piece of dirt. That's just a piece of soil that's been impregnated with the mycorrhizal fungi.
Oh, look at that. Check that out.
It's
Oh my
just
God.
amazing how many threads are in there.
There's trillions of them.
10 miles of threads in that little piece of soil.
Check that out, Doc.
And you
And
measured
that's
that.
what the plant, that's feeding the plant.
Gee whiz.
That's what's feeding the plant.
Get off of the roof. What are you doing? You're killing the flowers and stuff.
This is fine to walk on, Don.
You're gonna get stung by a honeybee.
No, I'm not.
Oh man, this is amazing. This is a true green roof. You've got solar panels and even a honeybee hive.
We do, and a recycling pond, and we tried to make the building as green as the company, so it's kind of a dream come true for us.
It's beautiful.
Yeah, it's been great.
Andrew, it collects all the rainwater and ends up in the pond.
Very cool. I've never walked on a meadow on top of a roof before.
You really shouldn't be doing that.
It's all right, isn't it, Doc? See?
I don't know. You're gonna get stung and you deserve it.
Now this is the bees over here, right?
Oh, look at the honeybee hive.
100,000 bees.
How many?
100,000 bees.
Now, how do you know? Did you count them?
No, the graduate student.
Isn't that amazing?
Man, why don't you dip in there and get
They
some?
like you.
I think you should open that and stick your head in there, Don. Now what is, on the screen here, it looks kind of like the inside of Don's ear hole. I've seen stuff like that crawl out of his ear before, but I know it's not that. What is it?
You're looking at the end of a root tip, and coming out of the end of that root tip are these filaments, these tiny threads. And they're an extension of the root system that go into the small spaces of the soil. And that's actually what we're producing, are these mycorrhizal fungi.
So when we were looking through the microscope at the spaghetti thing, that is basically exactly the same.
That's an electron micrograph picture of that with higher magnification.
So, Dr. Mike, you're one more example of an incredibly important business here in Southern Oregon. Why and how did you end up here?
Well, I think it was the quality of the environment. I mean, Don, we came here and it was a pristine area, and a lot of the natural ecosystems were still intact. And we actually developed a lot of the cultures that we use in our production from these natural areas that were so productive.
So there you have it, folks. Another fascinating business right here in Southern Oregon, making things happen. Another eco-gem that we found hidden away, providing jobs and providing a better life for all of us.